Hello dear students, welcome back to Technogate. I hope all of you are doing amazing with your subject physics and your preparations, right? So today what we are going to discuss is something which is of utmost importance for not only the physics subjects, for the other subjects as well, right? So this particular topic which we'll be discussing in this class is going to be very important for all of you out there, right guys? So I'm writing the heading already. Come with me. The heading for today is physical quantities. Now you will be saying, sir, we have already discussed what are the physical quantities. Sir, we have already discussed what are the physical quantities. Now, what is the difference between what we will study today and what we have studied so far? I'll show you the difference, guys. I'll show you the difference. Now the difference lies in the classification of physical quantities. Today we will be discussing the classification of physical quantities. Today we will be discussing the classification of physical quantities, and when I say the classification of physical quantities, that means I'll be making you familiar with two different things and two different quantities. One are the scalar quantities and the another are your vector quantities. One is your scalar quantities and another are your vector quantities, right? So today we will be discussing physical quantities and their classifications in the form of scalar quantities and vector quantities. Now, before we enter into the topic, let me tell you, on this planet Earth, whatever the physical quantities are existing, the study of those only we have described as physics. Now, this physics or these physical quantities will be studied in the two forms. One of them will be the one having the magnitude only and not the direction. The others will be having the magnitude as well as the direction. Now this sounds very simple, but when we dive deeper into the concept, this concept isn't that simple. Let me tell you, let us write down the definitions first. The scalar quantities are the quantities having only magnitude. I am writing a word here, that is magnitude. And on the other hand, or on the contrary, the quantities having magnitude plus direction. The quantities having magnitude plus direction are named as the vector quantities. Let me put the main key concept in the box. Here the key concept is magnitude, and here the key concept is your magnitude plus direction, right? So let me summarize the concept for you. Those physical quantities which will be having magnitude only will be named as the scalar quantities, and those quantities which will be having only the magnitude plus direction will be named as vector quantities. Now let us understand the major difference between the two. Now when I write the word magnitude, what is the meaning of it? The meaning of the word magnitude is, suppose I'll quote a famous example on another page. Now we have two different parameters. One is distance and another is displacement. First, on this side is your displacement. Now what I'm writing on the left hand side are your vector quantities, and what I'm writing on the right hand side are your scalar quantities, right? So here we will be writing scalar and here we will be writing the vector, right? Now I'll explain you how both of them are different, right? Now suppose there are 2 points A, B. There are 2 points, right? Now when I say I have to travel from A to B, when I say I have to travel from A to B, I say that I'll be moving in this direction. But when I say that I have to travel to B, but I have to travel via C, here is another point, that is C. Now I am reaching the same point B, but I am traveling through some other location, right? Now when I am traveling through some other location, obviously the distance covered seems to be more. Now suppose this distance is 100 kilometers and both of these distances are also 100 kilometers. Now when you are telling your friend that, my dear friend, when you are going from A to B, you have to travel 100 kilometers. But when your friend traveled, he actually traveled 200 kilometers. Why? Because you did not tell him in which direction to go. So when you have to tell your friend that, my dear friend, you travel from A towards B, you travel from A towards B in this particular direction, then you have to travel only 100 kilometers. What is the difference between the two? The difference between the two is, when your friend is traveling in a specified direction, he is going along the displacement. But when your friend is going randomly, he is reaching the same point B, but the traveled distance is more. So without direction, distance may be shortest or best, and may not be. There are chances that he may go along this direction. Your friend may be smart enough, but your friend may be stupid enough also, that he is reaching B, but he is traveling a lot more points. Similarly here, your friend is reaching B, but when direction is specified, it is obvious that you take the best route. Now this example must be making it very clear in your mind the importance of direction, right? Now when you are traveling from one place to another place, this is just the basic simplest example which I could give you, that when we are traveling from one place to another place, if we are specifying the direction, it becomes much easier to travel 100 kilometers and the shortest and the best path. Whereas on the contrary, on the other side, if the direction is not being specified, your friend may be traveling in so many directions, though he is reaching the same point, but the distance traveled is 200 kilometers. So you must be knowing that if the direction is specified, your friend is saving time, energy, money, everything. So when I am writing, now let me come back to the concept. The concept says, when I am writing only the magnitude, what is the magnitude here? This 200 is your magnitude. This 200 is your magnitude. This is what your unit. This is what your unit. So when you will find something only with the magnitude, with the unit, we will be calling it a scalar quantity. Now when you will find 100, what is this? This is again a magnitude. When you will find magnitude with unit, but here you also has this direction, you will also have the direction. This is what we have written. Whenever you will have magnitude plus direction, both, unit is common in both the quantities, or in every quantity unit is common. But when only the magnitude is given, this is going to be a scalar quantity. But when the magnitude plus direction both are given, this is going to be a vector quantity, right? So this is what my concept is. Now coming back to the classification, when you have only the magnitude, and obviously plus unit, and obviously plus unit you will always be having, unit is always there. But when you have only the magnitude, it is going to be a scalar quantity. When you have magnitude plus direction, it is going to be a vector quantity. Now if I have to write the examples of it, I will write the examples quite comfortably because you have already understood the concept. The first example is your distance, and here the first example is your displacement, right? Similarly, you will be finding more examples in the physics. We will be discussing them with due course of time, right? And these examples will keep on making the concept more clear, but this will happen with time. For now, distance, displacement, the other is speed will always be a scalar quantity, and velocity will always be telling you the direction also, so it is going to be a vector quantity, right? Similarly, there are n number of such examples which will be telling you what are the scalar quantities and what are the vector quantities. There will be n number of such examples, like if you say energy, it will be a scalar quantity, right? Though this is an exception, this we will be discussing separately in the next third, fourth slide. This is going to be an exception. Sometimes it will be having the direction, sometimes it may not be having the direction, but we always study energy as a scalar quantity. We will always be studying energy as a scalar quantity. Another famous example is your acceleration. Your acceleration will always be having some direction, whether it is going to accelerate or it is going to retard. So this is always going to be a vector quantity, right? So energy you will always be studying in what? Your scalar quantities. Also, if I want to quote some more examples, time has no direction. Time is a scalar quantity. We do not have any direction of the time, right? Do we say time is going towards east, time is going towards west, time is going towards south? Do we ever say that? No. So time is a scalar quantity. Mass is a scalar quantity, right? But when on the contrary, when I say weight is going to be a vector quantity. Because why? Because weight, do you know the difference between weight and mass, my dear students? Mass is what? Mass is the actual space occupied by your body, right? Weight is what? The actual space occupied by your body acting towards the center of gravity of the earth, or it is always having the concept of acceleration due to gravity. So this is m, and weight is m into g, and this is acceleration due to gravity. This always acts downwards towards the center of earth, or you can simply say it always acts towards the surface of the earth. We are standing on the surface of the earth because of the weight, not because of the mass. Your mass will remain same on any planet of this universe. Your mass will remain same on moon, but your weight will keep on changing depending on the g value of the planet. This you must have read earlier also. If not, I have again made it clear to you, right guys? And we will also be discussing it in the coming future. Alright guys, so we have discussed the difference between scalar and vector quantities in the form of the definition. Right? With the examples. Now coming to the next part. This is also clear to you, what is distance, what is displacement. The next part what I have to convey to you guys is that the addition of scalar quantities. The heading is addition of scalar and vector quantities. Addition of scalar and vector quantities. How these two are different? Right guys? So I'll just give you a brief of it for now, because addition of vector quantities is an entirely broad topic which we'll be discussing in the coming slides, right? For now, scalar quantities have only magnitude plus unit, so they can be added like a normal numerical value. Now what is the meaning of it? See guys, I'll explain you it in detail. When we are adding two parameters or when we are adding two scalar quantities, what is the meaning of it? A scalar quantity is having only the magnitude. What is the magnitude? It is having a numerical value like we had 200 and a unit that is kilometers or meters or whatever it is, right? So suppose we are having two distances we are having, right? One distance is 100 kilometer, another distance is 50 kilometer. Now when these two are the numerical values and this is the unit is not making any difference, so they can be added very simply like 100 plus 50, it is giving you 150 kilometers. So these scalar quantities can be added very normally. How? Like adding the two numerical values. So addition of the scalar quantities is quite easy. How it is easy? I am repeating it again. I guess I hope the screen got blurred a bit. Anyways, scalar quantities can be added simply like a numerical value, because it is 100 kilometers, it is 50 kilometers, it will be 150 kilometers, right? Because it is nothing but the numerical value. Whereas when we discuss about the vector quantities, on the contrary, when we discuss about vector quantities, there is some speciality of it. They cannot be added like normal numerical values, because they carry direction with them. So what is the difference, my dear students? Direction with them. Let me explain, right? Now suppose you are going 100 kilometers A to B, you are going 100 kilometers in this direction. Now I say you are going from B to C in this direction, again 100 kilometers. So you can easily tell that distance traveled from A to B and B to C is what? 100 plus 100, 200 kilometers. But what is your displacement? This cannot be told. Why? Because displacement is not going to be this, displacement is going to be this line. This line is going to be the displacement. Now when this line has to be considered, this cannot be added like normal numerical values, because it is having direction with it. One direction is this, another direction is this. So when we are having two directions, one is this, another is like this, right? So this cannot be added like numerical values. So how it will be added? Addition of this is done. Addition of this is done by triangular law of vector addition. Now do not get afraid of this big word. We will be discussing it in very detail. Triangular law of vector addition. So from this slide, what we learned that scalar quantities can be added like normal numerical values, whereas in order to add vector quantities, we cannot add them like normal numerical values. We need the addition of this can only be done with the help of triangular law of vector addition. You guys just see it once and let me have a sip of water, then we will be proceeding to the further topics, right guys? Now I'll quote an example, I'll quote some exception to you guys now, right? I hope this concept is clear to you. What is the value of this scalar quantities, how they will be added, but vector quantities we will be discussing in detail. Now I'm giving an exception to you guys. What is the exception? The exception is of electric current. The exception is of electric current. Let me tell you how it works. Now let's say electric current, how it will work? Suppose this is the one particular wire from which the current is coming, right? And from this direction also current is coming, and it is going in this direction. Now suppose we are having 3 amperes from this, 3 amperes from this, or let us mark 4 amperes from this. We are having 4 amperes from this. What will be the resultant current in this particular wire? This is going to be 7 ampere. Now we added them, though they have direction, though the current have direction, though the current have direction, the current have direction, yet they can be added, like normal numerical values, numerical values. What you guys can see here is these can be added as normal numerical values. 3 ampere was coming, 4 ampere was coming, it became 7 ampere. Sir, you said that directions cannot be added like normal numerical values, but you are adding 3 and 4 like normal numerical value. So, my dear students, I have already mentioned, though the current have direction, yet they can be added like normal numerical values without triangle law of vector addition, without triangle law of vector addition. Now comes the concept. The concept here which I want to make clear to you guys is, though electric current is having what? Your magnitude plus direction both, but yet it is a scalar quantity. Yes, you heard it right, my dear students. This is a scalar quantity. Though it is having the magnitude, and direction both, but yet it is a scalar quantity. Why? Because they can be added like normal numerical values without triangle law of vector addition. So what is the conclusion? Conclusion is, even if some quantities are having direction plus magnitude both, if they are not following the triangle law of vector addition, they will not be coming under the category of vectors. Right, guys? Now, what is this triangle law of vector addition? We will see it in the coming slides. But for now, you have to keep this thing in your mind forever, that those physical quantities which are not following the triangle law of vector addition will not be considered at any cost in the vector quantity or in the vector category. Alright, guys? Now, I hope this is clear to you guys. Just see this once and then we will proceed further. Right? Alright, guys, now let us proceed to the next part. You will learn everything about the vectors. Do not worry, you will learn each and everything about the vectors. Now, here we will be discussing the representation of vectors. Representation of vector quantities. Just try to understand, my dear students. Till the time we do not know how the vector quantities looks like, till the time we do not know what is the speciality of vector quantities, how can I tell you what is the triangular law of vector addition? So very first thing which we have to discuss is the representation of the vector quantities, right? Now, In this, the very first point, we will be writing the points, right? In this, the very first point is a vector quantity is represented with the help of a letter and an arrow above it, right? So what I have written, just read it twice. A vector quantity is represented by a letter with an arrow over it. Now how it can be written? The meaning, what is the meaning of it? The meaning of it is, it can be written as, for example, suppose I have to write A as a vector quantity. A is a letter and an arrow over it, right? A as an arrow, or A is a letter and an arrow over it, right? So you understood how a vector quantity will be written. So did you get it, how a vector quantity will be written? A vector quantity will be written with an alphabet with an arrow over it, right? I hope this is clear to you guys, right? Now the magnitude, how it will be written? It will be written the magnitude, that is only the numerical value. Whenever I am saying the magnitude, now please understand, you guys are mature enough now. Whenever I will say the word magnitude, what will be the meaning of it? The meaning of the word magnitude will be the numerical value only. Numerical value only. Now whenever I will say magnitude, the meaning of it is going to be the numerical value only. The meaning of it will be the numerical value only, right? The magnitude or the numerical value only can be represented without the direction with the help of mode. Well, now what is this mode? I'll be telling you how it will exactly look like, right? I will just give you. Now if I write mode of vector A, it will be, how it will be read, how we will pronounce it? We will pronounce it as mode of vector A. This will be written as mode of vector A. Mode of vector A. What is the meaning of it? This is representing no direction. It is representing only the value A. What it is representing? It is representing only the value A, right guys? So whenever you will find mode of vector